Hello mathematicians. Today we are going to talk about area and perimeter of rectangles. So let's get started. First let's review what area and perimeter is. So if we're looking at this rectangle shape right here and we're discussing the area of that shape, area is a measurement of how many square units it would take to cover the inside. A lot of the kids will think of area as the inside, but it would be covering all of the inside area in there. And we measure that in square units. Could be square inches, could be square miles, whatever your unit is. Perimeter is often thought of as the outside. Sometimes that word right there in the middle of perimeter, the rim of something, like the rim of a cup is the outside edge of the top of the cup. So perimeter would be the distance around the rectangle where you would add up all four of your sides. And that is measured in units, inches, centimeters. It wouldn't be square units because it's a linear measurement. Whereas area is a square unit. How many square units would cover the surface? So we've been working on that in class, finding the area and perimeter given different dimensions, lengths and widths. So if I have, this is a 2 by 8, 2 inches by 8 inch rectangle, then if we need to find the area of that or the perimeter of that, of course we know if we have a rectangle, opposite sides are the same length. So there's all of our dimensions. And then for a perimeter, if we're going to find the distance around, we're going to add all four sides. So in this case, we have 8 plus 2, 8 plus 2. There are some different ways to kind of combine those numbers and make it easier, but the basic way is just to think about adding all four sides. 8 plus 2 is 10, 8 plus 2 is 10, so I know I have 20 inches for perimeter. For area, we're going to draw back on our knowledge of arrays, and when we're making an array, we are, now my little tiles don't quite match in there. This should be 2 by 8. So let me erase this so it matches. All right, so if I were going to do an array, 2 rows and 8, and these would probably be more perfect squares, but when we're drawing models, we can make do. 1, 2, 3, 4, 5, 6, 7, 8. So now if I make that array and I count up all of my tiles, I'm going to have 16 tiles. But we've also made the connection that I have 2 rows with 8 in each group. 2 groups of 8 is multiplication. So I can do 2 times 8 equals 16 square inches. So this builds on what we've already been learning about arrays and multiplication. And then the next step that we took it in 4th grade is to say, hey guys, you know what area and perimeter is? What is the connection between area and perimeter and factors and multiples that we were learning about as well? And hopefully, especially when you're talking about area, the connection with factors and multiples is really in that area component rather than the perimeter component. So hopefully boys and girls can look at this equation right here, 2 times 8 equals 16, and they can pull out 2 and 8 are the factors of the multiple 16. And you can even practice saying it. 2 is a factor of 16. 8 is a factor of 16 because I can use 2 and 8 in a multiplication equation to make 16. I can practice the reverse. 16 is a multiple of 8. 16 is a multiple of 2 because it takes 8 groups of 2 to make 16 and 2 groups of 8 to make 16. The more they have practice kind of just stating factors and multiples, it becomes easier. A common mistake is sometimes to say, oh, 8 is a multiple of 16. and you just get it a little backwards. And the reason 8 is not a multiple is we find multiples by skip counting. So if I skip count by 16s, I'm never going to land on 8. The multiples always, factors are going to be smaller than the multiple or equal to, and multiples are going to be equal to and greater than the whatever your starting point is. So now we've kind of done that for a couple days, and we're moving into multiplicative area. So now we're going to tie in what we did maybe a week ago, and we're talking about multiplicative comparisons when we're talking about things being 2 times or 3 times as large as another. So if I have 4 books and Miss Bell has 6 times as many as me, well, that means that she has more than me. She has 6 times my number. I can do times 6. Miss Bell has 24 books. So we're going to use that same times as many to talk about area. So right here, we've got a little rectangle, and I'm going to walk you through a problem. So pretend this is about, maybe we're making a sign or a poster, and we have some measurements. We know that the banner is 5 inches wide, and its length is 4 times its width. So we're not saying the length is 4. At first read, you might just want to pop a 4 on there, but that's not what it's saying if you read very carefully. They're saying that this length right here is 4 times this number right here, which is our width. So that means I need to do 5 times 4 equals 20. Now I have the dimension of the length. All right, so we're talking inches again here, inches. So now I have this poster that's going to be 5 inches by 20 inches. So if I needed to find the perimeter of that, I would do, again, think about the sides, all 4 sides, the distance all the way around, and I would add up all 4 sides. I'm going to kind of do a little bit of math in my head, but still write an equation. I know that 20 plus 5 pretty quickly is 25, and I have 2 25s. So that should give me a perimeter of 50 inches around my poster. Now if I wanted to find the area, now I don't really want to draw 5 rows with 20. That just is a little bit time consuming and tedious. So a shortcut way would just to think about, well, if I were to make 5 rows and 20, a way to solve that is with multiplication. 5 groups of 20 is 100 square inches. So my poster covers an area of 100 square inches. Another way you might see multiplicative area is like this. And I'm going to try to squeeze it in here and not erase this so you can still see it. But you might be given the starting area and then have to work kind of backwards to get your dimensions. So let me show you that one. So you might have a problem with a rectangle like this, and they start you out by saying, hey, that area of that rectangle is 24 square units. So I'm going to write a note right here. I know area is 24. I'm even going to write 24 in the middle, so I remember that that's area. Its width is 6 times its length. Its width is 6 times its length. Well, dimensionally, I probably didn't draw this in proportion, but it really doesn't matter. It doesn't have to look perfect as long as I'm dealing with the right numbers. So its width is 6 times its length. Let me think about what that means. That means that whatever my length is, the width is 6 times bigger than that. And then when I multiply those two numbers together, I need to get 24. So its width is 6 times its length, and it has to end up being 24. Well, I'm going to think about my factors of 24. What are the different ways that I could actually have a rectangle with an area of 24 square units? So I'm going to think about factors of 24, the different ways. I could do a 6 by 4, because that equals 24. Let me see. Is one of those numbers 6 times the other? Is 6 times 4? No, that doesn't seem to make sense there. So let me try another one. What if I try, 1 times 24 makes 24. Now I have to think. Is 24 6 times 1? Is 1 times 6 24? No, that's not 6 times bigger. That's 24 times bigger. What's another way to make 24? 2 times 12. Let's try that one. Again, you can see when you know your math facts, this is a little bit less challenging. All right, let me see. Is 12 6 times bigger than 2? So that means I have to say 2 times 6 equals 12. Yes, 12 is 6 times bigger than 2. So let me go try this right here. I'm going to put a 2 here. I'm going to put 12 here, and I'm just going to think about it. So is this number 6 times bigger than this number? Yes, because when I multiply 2 times 6, I get 12. And when I multiply them to find the area, am I getting 24? Yes, I'm getting a result of 24. So there is a little bit of trial and error with this type of problem. It might not come to you immediately. You need to kind of work out what some of your options might be to find the area, and then find the area that meets the parameters that your problem is giving you. These ones definitely are a little more of a brain teaser, a little more challenging, but certainly not impossible. And just write your equations, and that will help you a lot figure it out and think it through. And even talk it through like Miss Gray is doing right now. Talk it out loud, talk with a buddy, talk with a parent, talk with a sibling, and see if you can work out problems like that. All right, so area and perimeter of rectangles with a little multiplicative area twist when we're doing times as many. All right, remember we're just tying everything in that we're learning. Factors, multiples, multiplicative comparisons, they're all connected. All right, happy homeworking.